Alright, so in this lesson we're going to be looking at how to find unknown sides and unknown angles within right angle triangles using the trigonometric ratios. What we'll find is that when we're looking for an unknown side, there's actually a process that we follow, but there's ultimately two procedures that we're going to need to engage in order to think about how to get that unknown side. That'll be clearer as we actually attempt these two problems here. In fact, for solving any of these right angle triangle problems, it's the same process always. So let me start with the process. Let's begin. The process is this. First of all, find the angle that they're dealing with, that we're dealing with. Find the important angle. Now in this first triangle, you'll see that the important angle that we're trying to deal with is this one right here, 67 degrees and 22 minutes. 67 degrees and 22 minutes. Now what we do is we establish what sides do we have to work with and what is their relationship to that angle. So we've got this 7.6 and that's pretty clear, that's the hypotenuse. So let's give it a little h. Okay, so we know that the 7.6 is the hypotenuse. And the other side that we've got with respect to this angle, 67 degrees and 22 minutes, the other side m, that's an adjacent side. So we'll put a little a next to the m, and that represents an adjacent side. Okay, and so now what we do is we go back to the SOHCAHTOA and we try to remember which of the three trig ratios is it that actually will give us a relationship between adjacent and hypotenuse, and so it's CAR, the adjacent divided by the hypotenuse. So we need the cosine ratio. Now we begin our working. What we're going to have is the cosine, cos 67 degrees and 22 minutes is equal to the adjacent m over the hypotenuse, 7.6. Okay, and what we want to do is we want to find out what m is. So this is actually solving an equation, and it's a very simple type of equation. I know the whole cosine thing makes it look a little more complex, but actually it's one of the simple types of equations that you would have actually been working on when you were in year 7. What we need to do is eliminate this divide by 7.6, and the opposite of dividing by 7.6 is to multiply by 7.6, and whatever we do to one side of an equation, we have to do to the other side of the equation. So we end up with the next line, which is 7.6 times the cosine of 67 degrees and 22 minutes. That's what m equals now. Fortunately, we have our calculators, and our calculators give us a nice quick answer to this, and what we will find is that m to one decimal place, m is 2.9. So that's the answer that we get. M is 2.9 to one decimal. Now there's no units. So we weren't told it's centimetres or kilometres or millimetres or anything. So what we generally do is just write the word units to indicate that it's just a length that we're talking about here. 2.9 units. All right. Let's have a go at the second type of question here. In the second type of question, same deal. We start off looking for the important side or the important angle that we've been given and identify that first. Identify the important angle. So we've got this angle 39 degrees and 47 minutes. That's the one that we're going to be working with. Now look at the sides. What are the sides that we have with respect to this angle? Well, we've got 3.7 and that's opposite the angle, so we'll put a little O there. And we've got this Y and that's adjacent to the angle, so we'll put a little A there. And the ratio that uses opposite and adjacent is correct, tan ratio. So we write down tan 39 degrees and 47 minutes is equal to the opposite, which is 3.7 over the adjacent, which is y. Now here's the thing that makes this a little bit different to the first one, is that the thing that we're looking for here, it's in the denominator of the fraction. What we can do, a little trick, it's a pattern, it always works. If you want to find out why this always works, ask me in class, and then we can discuss it. We'll go through all the steps. But for the moment, I'm just going to show you the pattern, because patterns in mathematics are extremely useful and powerful things in getting through calculations quickly. The pattern is this: if the thing that we want is in the denominator of the fraction, then I can move it up to there, but this thing here, that's on the left-hand side of the equal sign, is going to go into the denominator of the fraction. So what we'll end up having is y is equal to 3.7 over tan 39 degrees and 47 minutes. Okay, and what you can do is just put that into your calculator. Write it into your calculator exactly as it looks like there. Okay, and your calculator can handle all of that. And when we push all the buttons and put it into our calculator, what we'll end up with is that y is equal to 1 decimal place. Y is equal to 4.4 metres. Okay, this time we actually were given units in the question, so include those units in your answer. That makes the answer complete. Okay, 3.7 metres is given here. It implies that all of these measurements are in metres, so our final answer should have metres as well. Right, so now what we need to do, that's finding an unknown side. Finding an unknown angle is a little bit different. It's just a little bit different. Okay, the process is going to be the same. We start off by identifying the important angle. We've got this angle here. It's an unknown angle. We don't know what it is, but we're going to find out what that angle is. Okay, now that we've identified the angle, what are these two sides with respect to that angle? Well, the 5.7, that's opposite. That's the opposite side. So we'll put a little O next to it. And the 8.3, it's the hypotenuse. Clearly it's opposite the right angle. The hypotenuse is always opposite the right angle in a right angle triangle. So we'll put an H next to it. And then we recall, we're thinking SOHCAHTOA, TOA, what is the ratio? OA. That's what we need. So, we need the SO. S, sine. So we're going to have the sine of theta. Here we go. Sine of theta is equal to the opposite, which is 5.7, over the adjacent, which is 8.3. Sine of theta is equal to 5.7 divided by 8.3. So now here's the thing that we need to do with trigonometry, is just like subtraction is the opposite process of addition, it's an undoing process, and division is an undoing process of multiplication, and finding the square root is an undoing process of squaring something. Well, in trigonometry we have undoing processes too. And what I want to show you is that on your calculator, see that button right there, there's the sine button, and right above it is the sine -1. That's the one that we're going to be using. So to get that, we need to press shift and we go -1, right? So we'll use that on our calculator, but before we do that, we're going to write it on the board. So we'll have theta is equal to the inverse of sine, and then we put the little fraction into our calculator. Okay, we've got the fraction in our calculator. Oh, that's a pretty sloppy looking bracket. Okay, and we put that into our calculator, and what we find is that, this will just take me a moment, sorry, I should have kept my calculator going there. We go 5.7, fraction 8.3, and then we've got to close that bracket, and we get this. We get 43.373, theta equals 43.373, blah, 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 degrees. And the decimal just goes on and on. Now, the truth is, that's a decimal answer. And we might not want a decimal degree answer. We may want an answer that's like these degree angles here, which is degrees and minutes. So to do that, what we do is, another little close-up of the calculator, see that little button there, the degrees, minutes, seconds button. We want that button right there. Okay, so to change this answer, we just press that button, and hopefully you'll be able to see on the display as I press that button, then it changes our answer. So now it's in degrees, minutes and seconds. If I press it again, we're back to decimals, but we want degrees, minutes and seconds. Alrighty, so what that tells us is that in degrees, minutes and seconds, it'll be 43 degrees and 22 minutes. Okay, you've got plenty of questions to work on now, and that's what you ought to do, is have a go. Just practice, practice, practice. Make it so it's just all second hand. Practice the SOHCAHTOA thing so that you just know exactly which sides go with which ratios when we're trying to deal with each particular angle. And enjoy your time doing some trigonometry.